So let's talk about safe Kotlin. So what does safe mean? You might have some clues already because you probably know the words like type safety, that is saving us from type problems, using the incorrect use of methods from some other types, of memory safety, that is protecting us from memory problems, and null safety, that is protecting us from incorrect use of null reference. So you might see some picture that safety, something is safe if it protects us from some kind of mistakes. And that's exactly what safety is. Safety means protection against danger from inside system, that is, from ourselves basically. So from the inside bugs. It's a very different concept than security. Security is a protection from outside threats that are mainly hackers, viruses, and other kind of security threats. So we are going to talk about safety, that is about making our programs more correct, less prone to errors. And apparently Kotlin is considered a very safe language, not only because of the strong type safety, good memory safety mechanism, and the modern null safety mechanisms, but also because of the design that help us make a better code. And this is what I'm going to talk about in this section. This is what I mean by the safe Kotlin. This presentation is based on my book, concretely on the first chapter. As you see, it's a first chapter, so in a way the most important one. Many people will probably only read the first chapter, and I decided to make it first because safety is, for me, the most essential. It's most essential programs to act properly, to work properly, and that's why I would like to talk about it today. So there are a few parts of this presentation. The first one is concentrated on mutability. Mutability always has been connected to safety, and mutability is in general considered problematic in terms of safety. So the first rule is to limit mutability. So what do I mean by that? Mutability can hide on two places in Kotlin. So one is using var, another one is using mutable objects. That's very generic description, but basically nearly everything that you have can lead to one of those two. Even arrays that are mutable are also kind of an object. So why do we want to limit mutability? So first of all, mutability makes it harder to reason about the code. So the more changes, the harder it is to think about the code. That sounds pretty obvious. If there are three things to think about when you are analyzing the code, three things to remember when you are analyzing the code, it's relatively easy. When there are 100 things that might change and interoperate with each other, it gets extremely hard. So in general, every mutability point is something that can change, something that can interact, something that needs to be analyzed and remembered, and makes just harder to reason about the code. But in terms of safety, another one is pretty important. It is hard to synchronize mutability in multi-threaded programs. And I will show you a few examples over time, starting from this very simple one. So here we have 1,000 threads that are increasing a number num. And you might guess that even though the perfect answer would be 1,000, it's highly unlikely it will be 1,000, because it's very likely that here we are modifying one variable by multiple threads at the same time. So it's very likely we'll have some conflicts, and that some of the numbers will be lost. So we will have maybe 973, 984, etc. If you have troubles with those code snippets, stop your presentation and think about it. I think you can do that if you watch it online. Okay, how about using coroutines? Well, sorry, not really helpful. We still have a critical section, we still have multiple threads, so we still have less than 1,000. Mutability needs to be properly synchronized. In terms of threads, it is to use synchronization block, so this synchronized with some lock. In terms of coroutines, there are better tools that are not blocking threads, so either a mutex or a dispatcher with a single thread. But nevertheless, when we have some mutability point, this needs to be synchronized, and it needs to be synchronized properly, and that is often hard. Another thing is that mutability makes it harder to test. So whenever we test something, here we have an example mutable object, bank account. It has some internal state that is balanced. So we need to, whatever function we test, we need to test it not only for the space of possible arguments, but also for the space of possible state. So the more state, the more space we have. So the more mutability, the more we need to test. So from experience, it gets really complicated if we have multiple interacting parts, variables in some object, because you can easily miss some configuration that is from some reason problematic. So again, mutability is important, it's essential, in many cases it cannot be omitted, but it's better to limit it, to use it as little as necessary. Another one is that it is often that when state mutates, something else needs to be updated. Very often it is some outer object, sometimes this is some other object. So a simple example is if you have some list adapter, you change its data, you probably need to redraw the whole view that represents this list. Yeah. A simpler and more universal example is, imagine that you have a sorted list of elements, let's say sorted set from the Java library. So you have a sorted set of elements. Those elements are sorted by user ID, and imagine that those are mutable users. So what one could do is just take one of those users and change its ID. So what happens now is that this object is at incorrect position. So imagine that someone is looking for this object, exactly the same object. Yeah, so it is in the set, but we are looking for it, and the algorithm looking for elements in a sorted set is of course not looking one after another, because it would be an absurd. It assumes that the set is sorted. So to have a better complexity, it looks at the position where the element is supposed to be. So since the element is not where it is supposed to be, it won't be found, and so the set cannot be trusted. So mutability does not work well with outer objects. Outer objects often needs to be updated, and this is something we need to have in mind. Okay, so how do we support immutability? Kotlin introduced a few features that are very strong support for immutability. The first one is fairly obvious. It is distinction between val and var, and a much more common use of val. So you know that in Kotlin we have var, that is read-write property, and val, that is read-only property, meaning that val cannot be modified. This is a very strong thing, very useful thing, and we found it very useful. We prefer val because val is not making mutation points. Although I need to warn you, val can still keep something that is mutable. Well, that's fairly obvious. But even if val is keeping something that is immutable, it still can be changed in some situations. So if you, for instance, define val using a getter, like here we have val full name, it means that full name cannot be changed, but it doesn't mean that full name has always the same value. Yeah, in this case, full name depends on name and surname. So if one of them changes, the value returned by full name changes as well. So in this case, even though it's val, it might give you a different value every time you use it. That's a nice balance because it gives us a lot of freedom. But still, if we have a choice, we generally prefer vals that just do not change. We are not creating mutation point, but using this kind of val, and we have a lot of freedom in the same time. So that's nice. But if we have a choice, having true immutability is considered better. A very similar mechanism is used in terms of collections in Kotlin, and that's a very useful feature of Kotlin, that we have a strong distinction between read-only and mutable collections. But very similar to val and var in collections, the distinction happens on a level of interfaces. So we have read-only interfaces, iterable collection, set, and list, and we have read-write interfaces like mutable, iterable, mutable collection, mutable set, and mutable list. What means that if you have a mutable element, you can always upcast it to a read-only variant of this element. So you have mutable list, you can make it a read-only list. So by that, you eliminate mutation points. You restrict someone from modifying that, and that's nice. But notice that under the hood, you might still have a mutable element. In general, you generally do, and so that can still change. And so in some cases, it makes a difference. So I will show you that in a moment. First, I would like to just warn you to not leak mutation points. So here we have a in-memory repository that in different variants can be found in some projects. So this one is, I hope it's clear, is very poorly implemented. Yeah. So this one, we just have some mutable map of users. It could be mutable list. It's just I didn't want to work on talk about lists only. So here we have a map from some int to string. And we have a method that allows us to return all those users. So what we do in here, what's the biggest problem in here, is that we are leaking mutation points. We are what we are doing in the load all is that we are actually returning a mutable map. We do that implicitly, but we do that. And when we are leaking a mutable object, we are making it possible for someone to modify the mutable object from outside. Yeah, so someone can here use a setter to change the map outside of the repository. And then when someone asks for the repository again, it's different. Someone changed it from outside. So that's bad. That was a common problem in Java, like leaking mutation points. So Java solution was to use copy. In Kotlin, it could be two mutable map. So it would be better, but still considered not a good practice. A much better practice is if we hide mutability. So if we replace this mutable map with a map interface. So now it's safe. No one can modify it from outside in terms of limiting mutation points, because there is still a problem in this approach. There is a problem in terms of multi-threading use. So I will show you a very similar example. So here we have a list of users. I made some of them, to make what I want to show more visible. I have load all that upcasts it to a list. That's nice. By upcasting it to list, I make it impossible to modify it from outside. So I'm not leaking mutation point. That's nice. I also have a method add user to add another user. And that looks good. That's a very common in-memory user repository that you can find in many places, in many projects. But I just want to warn you, it's not thread safe. It's not fully thread safe. So to show you why it's not thread safe, take a look at this example. Here we make a repository, we take a list of users, and in two independent threads, in one of them we are iterating over those elements, and in another one we are adding an element. So what is happening is that it's nearly sure that during the iteration over the elements, someone will try to add element to this list. So we are trying to we're adding an element to exactly the same list we are iterating over. And you might know that this is illegal, so we cannot do that. So you see, this is the point where addition was trying to be done, and we have concurrent modification exception. You just cannot add into a list when you iterate over this list. So apparently, to make it fully thread safe, we would need to make a copy as well. That's one way. That's nice, or we could just use a read-only list. So instead of using mutable list, we could use normal list, and here do something like that. Yeah. So I just need to warn you, this solution is generally slower because every time we add an element, we are making a copy. So if we are adding many elements, we are making many copies. So and now we do not need to make this copy in here. So this solution is generally considered slower in terms of performance. But in terms of safety, using read-only collections and var gives us more safety. It's easier to maintain proper thread safety. It's easier to control how changes happen. One of the advantages of this, so those are two approaches. One is to use a mutable element and val. Another one is to read-only element and var. So the big part, they are very similar. As I said, mutable one will always be faster in terms of performance, but in general, the read-only one and var will nearly always be better in terms of safety. It's easier to make it multi-threading. It's easier to maintain the changes. It is easier to observe how the changes occur. So here we can observe using a delegation. What is the essential thing is to never use unnecessary mutation points. So having a var and mutable is something that should never happen. Another tool that Kotlin gives us is that instead of having objects that are mutable, we can have a data class, and data class give us a copy method that let us easily make a mutation inside. So we prefer to have read-only objects for many reasons. So immutable objects are much easier to maintain, much better to construct other objects, and they are also safer to use in many kind of collections. So here we have another example where we have a set and we are adding a person to this set. We are modifying this person, and you can see that this, even though this person is in the set, it cannot be found. Yeah, so we check if person is in set. We have false, like it is not, but it is in the set. It is at the first position. So how does that happen? The mutable set uses a hash table under the hood. The person was placed in some bucket. After the change, it is supposed to be in a different bucket. So using mutable objects together with hash set together with set is not a good idea, just like with a map and many other kind of data structures. So generally, mutable objects are considered very problematic in terms of many kind of other objects. So as I said, what we generally tend to do is that instead of having vars, so having them mutable, we prefer to make some kind of copies with something changed. Yeah, so we need to change user. We have, let's say, user Maja Markiewicz. She changed her surname. So what we used to do is we used to define some methods like with surname that allowed us to make a new version of the same user, but with something changed. And that is how we used to do that. But defining all those methods was just annoying. So here is a Kotlin for help. It introduced the copy method in the data class that lets us make a copy with some property changed. So those are the most essential parts of Kotlin support for immutability, distinction between val and var, distinction between read-only and mutable collections, and copying data classes that, thanks to that, we can easily define read-only objects. And if we need to kind of change them, we are making a copy with something changed. And that's considered the good practice for designing our applications. So the summary: we prefer val over var, we prefer immutable over mutable, we use copy to make another variant of an object with something changed, and we try to design our mutation wisely, not produce unnecessary ones, and do not expose mutable objects. Another part of this mutability discussion is to minimize the scope of variables. So that, I hope it's quite clear, so I will not elaborate on that too much. It's just that if you can make something, make something in smaller scope, we practically always do prefer that. So we are not defining things outside, except for some constants, some magic number constants. We are trying to put things in as close scope as possible, as close to the usage. Why? Primarily to have less to think about. You can more easily see what's the value of something, how is it calculated. You can see that this it's important only in here, not necessarily on other places. So you are not looking for other kinds of usages. So it's just the same part of the same discussion. Less to think about, less to consider, easier to understand our code. So we prefer to minimize the scope. I also have a really nice puzzler in the book, but I decided to omit it as we have limited time. So let's move into the next section that is dedicated to typing. So when we interoperate between Java and Kotlin, when you have the types annotated properly using nullable or not null annotations, we are trusting those languages and using in Kotlin properly nullable or read-only as nullable or not nullable types. But what if we are not having any annotation on the Java side? We do not like this situation, and we try to eliminate it as much as possible. So many annotations are supported, and they should be used on the Java side if we design for Kotlin usage. But if, anyways, we have a situation where we have not annotated type that is returned, what is actually returned there is called a platform type. If you check it, it's displayed as a type with the exclamation mark. So the platform type is a type that is not yet decided. So it still might be nullable or not null. So it can be used in both ways freely. Platform type is the best we could have, but at the same time, it is something that we should be eliminated as soon as possible. because we do not like platform type in our typing system. So imagine two situations. In both, maybe we started, maybe we used something from Java, and we are wrong. We used it as not nullable, where it turned out to be null. So in both cases, we are wrong. We use it incorrectly. In the first case, we haven't specified any type, and we just use it directly. So what will happen is a null pointer exception. But if you take a look at what's in the exception, you will see that there is absolutely no concrete. There is just some generic null pointer exception and this line and no other information. So that's not very helpful, and that might be a very long line and something very complicated. In the same time, if you specify the type, then you have a very concrete null pointer exception with an explanation that the null come from this method, and it's supposed to be not nullable where it's null. So that kind of problem is much easier to find, especially if you have more things that that are using platform types. So in this case, specifying the type and eliminating platform types is very useful and improves our safety. Also notice that this is especially important if we know that something is nullable, because if we would know that something is nullable but not specify it, we could use it 100 times safely. And then after a year, some other developer will come into our code and in one place start typing value dot, and we'll have suggestions like it is not nullable, and we'll do that, and something will, and this line will break with null at some situation. Yeah, so it's generally much preferred to eliminate platform types. It is especially visible if you see how it interprets with our typing system. So here we have interface. Its result type, its return type is inferred from the right side, that is from Java, and this is inferred as a platform type, so a string exclamation mark. So it means it's not decided. In the declaration side, it could be string nullable, and in the use side, it could be string nullable, not nullable. And this way, we are having a runtime null pointer exception in Kotlin with null returned, produced and consumed in Kotlin. And no warnings in here. In here, everything is fine. There is only one warning that should be respected. It is warning in here. If you have an interface where platform type is inferred, you have a warning that I updated in my IDE into an error, because this is something that is very badly interpreting with our typing system. Please specify types of your functions. Eliminate platform types. Another thing connected to that is that type inference is exact. Yeah. So here we have an animal and zebra. So if we have some variable that is zebra, we cannot make it an animal later. Why? Because by default the animal was inferred as a zebra. So we would need to make it explicit that it should be animal to make it possible to upcast it to some other things. That's a common case with some sealed classes. Actually, okay, but that's easy. That's easy to solve. That's a local scope. But it's not so easy to solve if you are a library creator and if you are designing some API. So here I have a story for you. Story from my country. So imagine that you are making a library when you are providing a way to produce a car. So you are defining a way to specify a car factory, and since there is one car that is produced pretty often, you decided to make it a default car. And what is more, since it's produced very, very often, you just make it the default thing that will be produced by this factory. And then you think, hey, this type in here is not needed. You can just skip it. That's something that will be inferred anyway. But then someone on the other side decides exactly the same thing. Hey, this car in here is not needed. I can just skip it and save a few lines. And congratulations. This way you just make your factory produce, all your factories produce only one kind of car because the inferred type is fiat, and your streets are full of the same cars, And this is exactly what happened in my country, and let's not let it happen again. So do not expose inferred types. That's a general rule, general good practice for library creators. The types that are part of your API should be rather expressed implicitly. It's much easier to understand that, read it, etc. By the way, currently we have strict mode that, as far as I'm concerned, enforces that. So if you are a library creator, use it, please. And the last section, let's talk about our expectations, just like last sections in a job interview, the same in here. Our last section in this presentation, let's talk about our expectations. Setting expectations is a very important part of programming, and in Kotlin we have some specific ways to set our expectations, especially on arguments and state. So we have a method require that is a universal way to set our expectations on arguments. So you can place it at the beginning of a function, and this function checks if what is required is true. So here we require that n is bigger or equal to 0, that points is not empty, that user email is not null. So this is how we declare our expectations. And if the expectation is not fulfilled, then illegal argument exception will be thrown. So that's a universal way to express that the argument is incorrect. So that seems very legit. We can also specify the exact message. So we can specify the lazy message using lambda expression to not produce it when it's not needed. So if n is not bigger or equal to 0, then we throw illegal argument exception with message cannot calculate factorial of n because it is smaller than 0. So this is the same rule applies to other ways to specify expectations. So check is very similar to require, but it is used to specify expectations on state. So it throws illegal state exception. And we also have one that generally works only on unit tests. So I'm talking about assert on unit tests, and if you have a proper flag set. But I also see it sometimes used in a code. So in a code, it won't be actually invoked in the production. Yeah, it will be invoked on the unit tests. But if you truly care about unit tests, if you do a lot of unit tests, then moving some of them inside your code is actually beneficial because it's much easier to test some things over there, and then they are tested always, and they are also a part of setting expectations. So someone reading this function can read that, hey, this one is expected at this point. By the way, this is not a common practice in Kotlin, but it's quite a common practice in some other languages like Python, where asserts inside a code, especially in some projects, are very common. So it throws assertion error. And if you want to have it on outside of unit tests, you need to have a flag EA on JVM. So why? So here we have all those ways: require block for expectations or argument, check for arguments for expectations on state, assert for basically for testing something. We also have Elvis operator and return with throw that we will see a little bit later. Here you have them all in use. So here we check argument, here we check state that something is open, here we assert the size of returned collection. So specifying your expectations like that at the beginning of the function is considered very good practice. It's a very, very idiomatic, because this way the expectations are very visible, just like annotations. You see the function, bam, you immediately see what is required from you. They are visible. They are also not letting something wrong to happen. So they are throwing an exception. So this is blocking incorrect use of the function, and as a result, it's protecting this function. So instead of letting incorrect value modify our state, maybe make some changes in the database or wherever before it breaks, it is stopped at the beginning. And it also make our code more self-checking. So if you are about unit tests, if you are about making your code work well, then this is very useful. So all the expectations. We also have other functions, other exceptions, standard exceptions that we throw in other situations. I describe them in the book. It's good to know them. You likely know them already, but I just would like to remind you to prefer standard error exceptions instead of making your custom ones. But also you will find situations when it's better to write your own exception to signalize something concrete, like in here, JSON parsing exception that, signalizing concretely that JSON cannot be parsed. We'll get back to that. What I described in here was all part of offensive programming. So that's a philosophy that when there is something truly wrong with your code going on, you should express that visibly to not let that happen, to make it visible so that it can be corrected and does not interoperate badly with your program. And offensive programming as an idea was created in opposition to defensive programming that we'll talk a bit more right now. That is to handle your changes safely. And those two approaches seems to be in opposition, but actually they work perfectly well with each other. And always you need to know the strong sides of both of them. We use defensive when we want to silence something, when it's fine to silence something, but we should not use it when something truly wrong is going on, because if something truly wrong is going on, we prefer to make it somehow visible so that it can be solved, it can be corrected, and it is not just silenced, because if something is silenced like this dragon on the picture, it can grow and lead to much bigger problems that are harder to find later. So a big part of defensive programming is to So a big part of important suggestion in Kotlin is that instead of choosing exceptions to result something that is possible, something that is to some degree expected, we are not throwing exceptions for this kind of situations. We prefer to signalize it directly, and we signalize it either using null, that is a common practice if there is nothing concrete we would like to signalize, or something like failure. It can be either in arrow, it can be currently failure from the standard library cannot be returned, so it can be your own failure, but some kind of type that will signalize what's wrong. So doing that is considered much better when the problem is possible, much better than throwing an exception, because exceptions are not supposed to be used to signalize something that is to a certain degree expected. And exceptions should signalize truly wrong situations. And this is expressed really well in the language, in the Kotlin language, because Kotlin do not have checked exceptions. It only has, unchecked exceptions. Yeah, all the exceptions are thrown silently, so they all should be used to signalize something truly wrong, not something standard that should be handled. If you want to signalize something that is, to a certain degree expected, might happen, then we should prefer to have this result or nullable, like in here, because result and nullable can be, visibly handled. So they can be handled by some features like safe calls or Elvis operators or anything else. In terms of nullable, in terms of failure, using some kind of when expressions. So this is much better for us. It's also good to give options. So if you need to get element from a list, you can choose get, where you expect an element to be there. So if it's not there, it throws an exception. You can use get or null, that where you when you suppose that it might not be might not be there. So in such case, you are handling you need to handle null. And you can also have a get or default that returns a default value in case of element not being there. So those are different options for different kind of use cases and different degrees of sureness that elements is there. We can handle nulls in two ways. One way is to handle them safely, so to use a safe call, Elvis operator, or smart casting. I hope that's all clear. And another way is to use to handle nulls unsafely, to use the offensive programming, something we talked about already, to use require, check, throw an exception with Elvis operator, or even not null assertion, that is generally considered worse than other options that are more explicitly expressing what went wrong. Although if you have in some cases it's still good to be used. So I'm not supporting this extreme way of thinking that it should never be used. It's just it should not be overused. And the last part, a small thing about using resources. You might know that resources should be closed before they are when they are used. So like file needs to be closed when we stop using it. So we cannot just iterate over that like that. Instead, we should close the reader when we are done using it. In Kotlin, in JVM, this is not fully proper way of closing any resource. It's more complicated because close can throw an exception, etc., etc. So it's better to use a function use. So use is an idiomatic way to close any closable resource. Yeah, but in terms of collections, instead of using a reader, we might, so here I used use, where I just move a reader inside. So instead of using the reader, the function use lines. So use lines give us a sequence of lines that we can iterate over, and that makes our function nicer. What is more, use lines can be used as an expression, so return can be lifted outside, and this is the same function that we had before, but implemented properly idiomatically with Kotlin. So the last item, I will not elaborate on that, just just very short words that in terms of safety, of course, the biggest part is to write tests. So to test your code is the pinnacle of safety, and I think it's important for all of us to push for tests, for different kind of tests on backend, more unit tests, on front end. I mean, on Android also more unit tests, but front end, the web development is now more about UI testing. But nevertheless, tests are essential for safety, and I just needed to include a short and essential item about testing in the chapter dedicated to testing. And that's practically all from my side in terms of testing. My company is really good. I learned a lot about testing in Allegro, where we have many users, like every month a significant part of Polish people are using Allegro, that is like Polish Amazon, and because of a huge traffic, like millions of users, we are taking a lot of care about testing, and it seems to be working pretty well, because the stability of all the elements of Allegro is just amazing from me. So I'm happy to be there. The presentation is based on my book, Effective Kotlin, and those are the items for the sake of reference. If you want to have more materials about it, on my website, on the KT Academy, in the courses section in here, you can find the this part, Effective Kotlin Materials, where you can find recordings of different presentations, some extra materials, and other useful resources I'm collecting there. This is free, so you can access that. To access some of the workshops, you need to, some of the materials, you need to be our attendee of one of our workshops. You can also find many chapters of the book for free on the same website. So if you go into books and Effective Kotlin, you can find chapters that are available as articles. More and more of them we are publishing, because I would like to share those lessons with you. Those are the updated chapters, so I'm updating the book right now, item by item. Also, if you are interested in workshop, you can find it on the same book. I'm conducting plenty of workshops in Kotlin, but KT Academy also now has different trainers and different kind of workshops in different technologies. So I'm very proud of how it's developing and extending. So that's everything from my side. The recording should be found in here, just like the slides, the link to the slides. Thank you for your attention, and well, have a happy Kotlin.